Bismillahirrahmanirrahim. Today I will explain bond pair, lone pair, what is localized bond and what is delocalized chemical bond. And due to delocalization, how resonating structures could be formed and how resonating structures or due to delocalization any compound is stable with respect to other compounds which don't exhibit delocalization or resonance. And due to formation of bond pair, how dipole moment, what is dipole moment and what are resonating structures of benzene and how you can draw resonating structures of many compounds. So if you take an example of methane gas CH4, there are 4 bond pairs between carbon and hydrogen. When you take an example of hydrochloric acid, there is only one bond pair between hydrogen and chloro group. And when you take an example of methyl chloride, there are again 4 bond pairs, but due to difference in electronegativity, methyl chloride is polar as compared to methane, because methane has also 4 bond pairs, methyl chloride has also 4 bond pairs, but there is difference with respect to their dipole moment. What is dipole moment? When polar molecules are observed, they have a property of dipole moment. Actually, polar molecules exhibit a large difference in electrical charge. As chloro group, this group belongs to halogens. Halogens are electronegative compounds, are electronegative elements. In HCl, chloro, due to its electronegativity, it has ability to electrons, and when electrons are most of the time it is residing or sitting on chloride, it becomes partially negative, and as a result H becomes partially positive, delta positive and delta negative. So HCl is polar compound. It has also electronegativity. In CH4, the difference between the electronegativities of hydrogen and carbon is very negligible. So they are non-polar compounds. But in methyl chloride, 3 hydrogens, 3 bond pairs, and another bond pair between carbon and chloro. Due to the electronegativity of chloro group, most of the time the bond pair between carbon and chloro, carbon is partially positive and chloro is partially negative. So again, this is due to difference in electronegativity, this is polar, but the polarity between hydrogen chloride and methyl chloride is different. Both are polar, but dipole moment is different, because dipole moment is simply the measure of net polarity in a molecule. It is product of Q into D, charge into distance. So methane has 4 bond pairs, non-polar. Hydrogen chloride has 1 bond pair, but due to electronegativity difference between these two elements, chloro has negative pole and H has positive pole, one positive, one negative, dipole, 2 poles. are present in HCl. In methyl chloride, carbon has partially positive charge and chloride has partially negative charge. Again, dipole is present here, but due to the charge and its distance is different due to is the reason in the difference of both dipole moments, that HCl has different dipole moment and CH3Cl has different dipole moment. You can measure it. Now we have discussed localized bond, we have discussed delocalized bond, we have discussed bond pair, and now what is lone pair? In CH4 there is no lone pair, but in ammonia there are three bond pairs NH3, and on nitrogen there is one lone pair on nitrogen. In water, oxygen has two lone pairs and two bond pairs. In water, two bond pairs and two lone pairs. In ammonia, one lone pair on nitrogen and three bond pairs with three hydrogens. Now, when we take simple example of formic acid. In acid means anything which has an ability to donate proton, to remove proton, to liberate proton is known as an acid. So formic acid, as it is a good acid, it will give proton. After the removal of proton, conjugate base is obtained, HCOO negative, formate ion. Anything which is 8 oxalate, phosphate, sulfate, uh, are used for anything which is negative. Carboxylate, formate, phosphate, sulfate. So formate means negative because proton is removed. You know the structure of formic acid I have written. HCH bond pair with carbon, and this carbon has carbonyl carbon. C double bond O. One of the double bond is sigma bond and another is pi bond, and then it was this carbon was attached to OH. H is removed, so H, after removal of proton, O becomes negative because one of the electron from proton and one of the electron of oxygen itself, it is now in the form of negative charge. This negative charge is actually not present on this oxygen after the removal of proton. Now it forms bond between carbon and oxygen, bond pair, single bond, it forms double bond. Now carbon could not be pentavalent, it is tetravalent. Its, its valency will be disturbed if this negative charge is coming. It is becoming double bond. So what happens that the carbonyl oxygen attracts pi electrons towards itself because it is electronegative. It can easily accommodate any negative charge on it. So now this oxygen, which was attached to hydrogen, now it has formed double bond with carbon, and that oxygen which was carbonyl carbon is now with negative charge. Now it is no more carbonyl carbon, and when it is observed through different techniques, it is observed that both oxygens have negative charge 50%, and both oxygens, they have 50% double bond as well. So it is clear that this negative charge is not localized on any of the on any one of the oxygen. This negative charge is moving from one oxygen to another oxygen, and carbon is involved, so three atoms are involved. When bonding electrons are shared by two nuclei localized, when these electrons which are forming bonds, but it is not shared by two but more than two nuclei, simple, delocalized. When bond pairs, when electrons forming bond pair are fixed or between two atoms involving two atoms, two elements, it is simple, it is localized. But when bonding electrons are shared by more than two nuclei, this is delocalized chemical bond. Clear? Now, due to delocalization, there is possibility that many resonating structures are formed, as you have seen that though that oxygen from where hydrogen is removed became carbonyl carbon, and that which was first carbonyl carbon now is becoming 50%, yeah, half time O negative. So you can form two resonating structures with an arrow between, double-headed arrow, to uh, tell that these compounds are resonating structures. They are canonical forms, they are contributors. They are contributing in the actual structure of formate anion. One of the formate anion is not sufficient to portray the actual a true picture of formate anion. Both oxygens have negative charge 50-50%, or they have, or in other words we can say that both oxygens have ability to become carbonyl oxygen 50-50%. So these two structures are due to delocalization of this negative charge. Due to delocalization, there is possibility of two canonical forms, two resonating forms, two contributors. This is resonating form of formate anion. And delocalization is when you have to tell that this negative charge, that this single negative charge is resonating between two oxygens and one carbon. You represent it with dotted lines. Dotted line tells that the charge, it may be positive charge, it may be negative charge. In formate anion it is negative, so negative anion is not sitting on one oxygen, but it is delocalized between one oxygen, one carbon and another oxygen. Three nuclei are involved. So that dotted line is dotted line is amongst three atoms or three nuclei. This is delocalization. Now, when I told you about ammonia has three bond pairs and one lone pair. Sometimes uh, bond pair has ability to travel between two atoms, and sometimes lone pair has ability to travel between the atoms. So, summarizing, the delocalization of electrons increases the stability of a molecule by resonance. A- Any compound which has as many as resonating structures, it will be more stable. If a compound has 3 resonating structures, it is stable. But on the other side, if any compound has 5 resonating structures, it is more stable. So according to this theory, localized electrons exhibit normal behavior. A localized lone pair remains close to one atom. A localized bond pair travels between two atoms. So localized between two nuclei, two atoms. But when it is beyond or more than two atoms or nuclei are involved, it becomes delocalized. Now when I discussed HCl and methane, methane is non-polar because electronegativity difference is very much negligible between hydrogen and carbon. But HCl chloro is electronegative. Hydrogen loves to become positive by giving its electron to electronegative chloro. So it has a positive, it is positive side, and chloro is negative. Dipole, two poles, one positive and negative poles are formed. So polar molecules exhibit a large difference in electrical charge Q. This is dipole moment. So Q into T in charge into distance is known as dipole moment. Now canonical forms. In benzene we can draw many structures, but the famous one are two Kekulé structures, very closer because they are stable, so they are in 39%, and other Dewar structures, they are approximately 7.3 each, 7.3, 7.3, 7.3. But none of these five structures, none of these structures could explain what benzene actually is. So to solve this, scientists, they just make hexagonal structure like cyclohexane, and there is a ring showing that these 3 pi bonds, actually 6 electrons, they are delocalized equally amongst 6 carbons. This is true. We can say that this explain because none of these 5 structures in it, in first we are seeing that one carbon is showing single bond character, another is showing double bond, alternative single and double bonds are present. But actually we cannot say that this single bond is here, this double bond is here, because every time electrons are delocalized. How can say this is single bond, this is double bond? So uh, as many as canonical forms or resonating forms or contributing forms, the most stable is that compound is. So the different structures contributing to the resonance hybrid are referred to as canonical forms of the molecule. The more stable a canonical form, the more it contributes to the resonance hybrid, because Kekulé structures, they are more stable as compared to Dewar structures. So they are contributing major percentage of benzene. Hybrid means a combination of all the resonating or canonical forms or contributing structures. So I hope that you have clearly understood uh, these concepts. Now, what is resonance theory? It is that theory by which the actual normal state of a molecule is represented not by a single valence bond structure but by a combination of several alternative distinct structures. Now, my dear students, I have told you about negative charge on formate anion, how it is delocalizing between amongst three nuclei: oxygen, carbon, oxygen, two oxygens and one carbon, and that CH, this is bond pair, and C double bond O and O negative, these are delocalized bonds. Now you can write 5 localized and 5 delocalized bonds. It will become easier for you to understand. Then, what is the difference between delocalization and resonance? In benzene, you have seen that due to the delocalization of 6 electrons, or in other words 3 pi bonds, how possibility of not only these 5 resonating structures but more than 7 or 8 structures could be formed on the basis of delocalization. And due to delocalization, benzene is showing resonance because many resonating structures are possible. So the last one, draw resonating structures of acetate, nitrate, NO2 minus, carbonate, bicarbonate, benzene and phenoxide. Phenol, after the remove, phenol is an acid. When proton is removed from phenol, you can write many canonical forms of phenol. Now you have to tell that in acetate which is bond pair, which is lone pair, which is localized bond, how lone pairs or bonds are delocalized. So better to use different colors. You can tell that localized is you are mentioning localized bond with yellow color, you are mentioning delocalized bond with red dotted line, bonds green color. You can use in acetate lone pair delocalization, and in benzene double bonds. Clear? Delocalized double bonds or single bond. So I hope you will enjoy this lecture and carefully solve your assignment, inshallah.